Hey everyone. Thanks for coming to hang out and learn some SQL. The audio is probably going to be a little bit sketchy. I am on my headset right now. My laptop, as it turns out, has demanded that it should not be used for anything this intensive, anything as intensive as streaming video in my office in the afternoon, because it's just too hot in there. Let me know if you can hear me and if audio sounds okay. I am going to track the chat, but with my current setup, I don't have a way to keep it up on the screen all the time, so I'll just check back on it occasionally. All right. Today we are talking about SQL. Before we jump straight in and start writing SQL, I just want to sort of put it in context how you'll be using this potentially as a developer. SQL stands for Standard Query Language. It's a language we use to interact with relational databases, and I'll tell you a little bit more about what that means in a minute. SQL is going to let you create, read, update, and delete data from a database. And let's go back even a step further and talk about what a database is. You'll notice I've got Stack Overflow up here, so I'm going to sort of use it as an example. Most web applications need to be able to store some kind of data permanently. A database is just a common way to do that. Now, this is okay. This is actually not Stack Overflow, but this is the Software Engineering Stack Exchange. So same idea, just a very slightly different topic. If we look up here, we've got several different pieces of data represented on the screen that Stack Overflow has to store. In the top right, you've got my user profile. And if you click on this, you'll dig deeper and see that they're storing a few different pieces of information about me. They've got my username, they've got a bio, they've got my location, they've got my Twitter account, my GitHub account. They've got a URL for my website, the date I joined, and probably even a bunch of other stuff that maybe they don't show me. Then, if we scroll down just a little bit, right here we've got a question. So for a question, they're storing a title of the question, a body of the question. They're storing a list of tags that have been applied to that question, the time it was posted, the number of views, the number of upvotes, and the number of downvotes. And again, probably some other stuff that's maybe not exposed to the user. For answers, like this one at the top, they're storing kind of the same sort of stuff that they store about questions. And then underneath the questions and the answers, you have these comments. Those are being stored permanently. They're storing a body, the number of upvotes, the time it was posted, and some other things. These are each distinct kinds of data that Stack has to store. Each one is defined as what's called a table in the parlance of SQL and relational databases. I will say I honestly have no idea if Stack uses relational databases to store their stuff. They may store all this in a NoSQL database, which is something a little bit different. They might store it in files somewhere. But this is a good example of the concepts anyway. So one type of data would be stored in what's called a table. You can think of a table kind of like an Excel spreadsheet. It has columns that you name when you create the table. Well, one thing that's pretty different from Excel is, in addition to naming your columns, you're also going to define the type of data, and only that type of data can be stored in that table, in that column of that table. You can also define some other constraints on your column. Maybe you've got a column that should never be empty. Anytime there's a new record, this column has to have a value. That's what's called a not null constraint. Or um, you might have a table with a column that you always want to be unique for each record so that it's never shared. And that's just a unique constraint. A good example of that is like if you wanted to store users, you'd probably want each one to have a unique email address. So you might put a unique constraint on the column that stores the email address. One thing I said, and I didn't really go too deep into, is I said SQL is for relational databases. Now, let's talk about what that means. If we take this question, each question has a user who asked the question. Here's this one asked by Bevan, I guess. Each question has a relationship to the user who posted it. And you can define those relationships inside your database. That's why this is called a relational database. Most tables in a relational database have a column or sometimes a combination of columns that serve as a unique identifier for each record in that table. A record is just the database word for a row in a table. The unique value for a row is called the primary key, the one unique value that defines that row. You can use that primary key to create relationships with two tables. So what you would do is you would create a column in one of the tables that references the value of the primary key of a record in another table. And that sort of ties those two records together. Let's go into my user profile here. I know the visual here is not super exciting. This is just me talking a lot, but we're going to get into the meat of it in a minute once we have these basic concepts. Let's say I create a new Stack Overflow account. Well, let's just imagine that my account is the first one. So they give me an ID of 1, and that's going to be my primary key for my user record in their database. Then I pull up Stack, log in, and ask a question. The question table is going to have a column called maybe asker or something like that, user ID, something that tells us that it's referencing a user who asked that question. When I ask my question, the app is going to store a new record in the question table, a new row, and the asker or the user ID value is going to be 1. It's going to match the primary key of my user account. When you run queries, and by the way, a query is what it's called when you get data out of the database, you can join two tables together based on the relationships the records have. And we're going to actually do some of that tonight, so you get to see what that looks like in action. And another thing you might have learned from this demonstration is that SQL is sort of traditionally capitalized. The keywords in SQL are traditionally capitalized, but it's not necessary. A lot of people in this thread actually are saying that it was because SQL was invented before before format highlighting, so before syntax highlighting, excuse me. And it made it easier to see what was the syntax versus what was like a column or something like that that you were referencing within the syntax. We don't really need to do that anymore because we've got nice syntax highlighting. So today I'm just not going to capitalize anything. We are working from this project. This is a GitHub project. I'm going to paste this URL into the chat so you can get to it easily. All right. This is just a series of SQL exercises. It's pretty nifty. Takes us through a bunch of things. We're going to create a schema, create some tables. We're going to add records, delete records. We're going to do some queries, do some joins. All that stuff probably sounds maybe a little scary right now, but it's going to be nice and easy, I promise. Then the website we're going to use to do all this, we could set up an SQL database on everybody's computer. I think that would be a total nightmare. So instead, we're going to use this website. It's called DB Fiddle. I will also paste this URL into the chat. All right. And what this does is this just lets us kind of play with the database. We're going to be able to enter our queries and see what the result is. We are using the database engine MySQL 5.7. There are lots of relational databases that use SQL. It's mostly the same from one to the other, so you don't have to worry too much that you're learning on MySQL because most of this will transfer to whatever database engine you end up using in the future. And as far as relational databases, this typically will not translate to NoSQL databases like Mongo and can't even think of any other examples right now, but those sorts of databases do not use SQL. Let's jump into this and start writing some SQL. There's a little bit of setup here. The first thing we're going to do is jump into this schema.sql file. They're suggesting you run this in MySQL Workbench, but it's just as easy for us to run it in DB Fiddle. Okay, so once you're in this schema.sql file, you are just going to grab all the text, copy it, and then we're going to come over here to our before I go on, how is everyone doing? Are we doing okay? Everyone able to follow along? Any issues so far? While people are thinking about that, I will say schema is just a fancy word for the layout of your database. So what tables do you have? What columns do they have? That sort of thing. What is our next step here? Now we're going to actually start getting into some of the exercises. We're going to create a songs table. We're just going to shamelessly cheat and borrow heavily from the tables they have already created. Let's look at what they've done here. They've created a database, then they are using that database, which sort of switches context into that database. They are creating a table, bands, and these inside the parentheses are the columns they're creating. They've got an ID column, a name column, and then they are sort of declaring this ID as the primary key for this table. Then you go down here and they're creating another table, albums, and it's pretty similar here. They've got an ID, a name. On this one, they've got a release date and a band ID. The ID is the primary key, and then this foreign key sets aside a relationship to another table. So we're saying the band ID column references the ID column inside bands. Now we have an easy way to relate an album back to a band by referencing its ID in this band ID column inside the albums table. But what we want to create is a songs table. I'm going to start with this. That's what we need for the table. Now we just need the columns. The columns we want are ID, name, length, and album ID. First, I'm just going to lay them out like this. But we also need to go ahead and define any data types and any constraints that we have. This ID is an integer that is the primary key and auto increments. Let me show you some documentation that will be useful throughout this exercise. Pull it up in a different tab here. Since we are using the MySQL database engine, I am looking at MySQL documentation. I've matched the version number to what we're using. Let's flip back over. We're at 5.7. So I'm looking at the 5.7 docs. And let me bump this up so you can see it. I am looking at data types. This is what I'm going to use to declare the data type of my columns. I know the first one needs to be an integer. That's going to be a numeric data type. Let's drill down and see what the numeric data types are. Okay, we've got here are integer types. That's what we need. We've got tiny int, small int, medium int, and big int. What sets these apart is how much storage is allocated for them, which also determines the minimum and maximum values you can store in them. And those numbers will change based on whether they are signed or unsigned. If you can have negative numbers, then there is a shorter range on either side of the zero. And if you only can have positive numbers, then you can go a little bit higher since it takes the same amount of space to store. I am just going to use exactly what they used on the first example. They just used a standard int. Well, what were the other constraints? This is a primary key and it auto increments. This one's going to look a lot like the other ID fields. In fact, I think it's going to look exactly like the other ID fields. There we go. It's also a primary key. So I need to define that down here. Okay, we've got our ID column set aside. Now we have a name column. It's a string that cannot be null. Okay, I don't see anything in any of these that say string. So let's go back to our data types in MySQL. Oh, actually, it would be helpful if I shared this, wouldn't it? Cassie asks, how did you get to the 5.7 reference manual? I literally just searched for MySQL documentation or something along those lines. And then I kind of drilled down from there to find the data types. But feel free to just use that link directly. Let's look at the string data types. Looks like we've got quite a few different options. We've got car and varchar, binary, var binary, blob, text, enum, set. Just to be lazy, I'm going to use what they've used here. They've used varchar. So let's look at that. We can at least tell the difference between car and varchar. Car is short for character, so that means you're using alpha numeric characters, probably. Let's see if it tells us. I'm not seeing anything completely, totally obvious here. Yeah, I think it's alphanumeric. Yeah, so you've got characters, and then you've got varchar, which is just a variable number of characters. Okay. So let's do the same thing here. Varchar 255. That means the maximum number of characters we're going to accept in this field is 255. We also want to not allow a null value. A null value is just an empty value. We're saying that we don't want someone to be able to add a song to the database without giving it a name. Next, we are going to add a length, which is a float that represents the length of the song in minutes. It cannot be null. Length is a float and cannot be null. We don't know anything about floats yet. We don't have an example of floats. Let's refer back to the documentation. This is going to be back in numeric types. Fixed point and floating point. So I think floating point is what we need. I'm trying to see quickly if they tell us what the difference is. A precision from 0 to 23 results in a 4-byte single precision float column. A precision from 24 to 53 results in an 8-byte double precision double column. Okay, so it is the precision of the value, which I'm pretty sure is just how many digits can you have after the decimal. Okay, let's flip back over and create this. Float not null. I think that satisfies all our constraints. Float that cannot be null. Yeah, okay. The last one is the album ID, an integer that is a foreign key referencing the albums table that cannot be null. We can probably base this heavily on the band ID. It's int, it cannot be null, and then we also need one of these lines. Foreign key. This one's going to be album ID. References albums ID. That should do it. Now what we can do, there's not really a ton we're going to see here, but we can hit run, and I believe if it doesn't complain, then we are okay for now, as far as we know. No results to display, so that's good. I mentioned earlier what schema is. You can actually put any SQL in this schema SQL field. It doesn't have to just be creating tables and changing columns and stuff like that. It can be any SQL. The difference in these two columns in this application is that whatever you put in query SQL, you'll see the output to down here in the results pane. The stuff that's in schema, you will not see the output to. And you'll see why that's important a little bit later. There are certain things that we're going to run that we don't really want to see the output to. We just want the output from other queries, and we don't want to have to dig through a bunch of noise to see what we actually care about. Now, oh, okay, there's one more instruction on this one. After successfully creating the table, copy the code from data.sql into the MySQL workbench. And this is our data. We're just going to grab all of this. Now, this is something that we want to happen, but we don't want to see the output to it because it's not going to be very meaningful to us. So even though this is not really schema, we're really inserting data, I'm still going to put it in the schema column just so we don't have to deal with it. And you can probably look at some of this and tell what's happening. But just really briefly to go over it, insert into songs. So insert is saying add a new record. And then into is the keyword that says, and here comes the table that we're going to add it to. In this case, it's songs. In the parentheses, we have the columns that we're defining. You may remember that not all the columns had that not null constraint, so that means you don't have to define all of them. We ideally will tell SQL which columns we are going to give values for. In this case, it's the ID, the name, the length, and the album ID. Then we have values, which signals, okay, here comes the actual data that's going to be in the record. We've got 74, which matches or maps to the ID. We've got this, which I'm not even going to try to pronounce, which is the name. I probably just offended someone who loves that album, but apologies there. Then we have length, which maps to this. Okay, so what this is this is 5 minutes, no, 5 hours? I'm not sure. But anyway, 56 over 60 is going to give you the fractional value for 56 minutes. So that's basically converting the album, or no, the song's runtime. Yeah, so this is 5 minutes and 56 seconds. That's converting the song's runtime into a floating point value, into a fractional value instead of minutes and seconds, which we don't have a great way to store in this table. Then we have the album ID. This is just the ID of the album that this song is on. And every one of these is really like that. There are a lot of songs, and then there are a few bands, and I think that's it for now. Yeah, bands. Oh, albums. Yeah, here are the albums. All right. We can run this again. We won't see anything, but hopefully it won't complain. Looks like we're okay. Got the green alert. How is everybody doing right now? And while you're letting me know about any issues you have, I'm going to start looking at this second exercise. Select only the names of all bands. That should be a pretty straightforward one. All right, to get data out of the database and look at it, you're going to use a select command. So we'll start with select. The next thing after select is a list of the columns you want to see, separated by commas. In this case, we just want the name, right? Yeah, we want only the names of all bands. And if I look at our band table, the name column is just called name. So I'm going to say select name. If I wanted more columns, if I wanted to see the ID also, I could put comma ID, comma ID. That would give me both columns, but I don't need that here. And now, just like with those insert queries earlier, you had an into that said, here comes the table. With selects, you have from, and then here comes the table. We're selecting from bands. And that's pretty much it. There's one more piece that I'll show you in a minute, but first let's look at this. Also, I am going to terminate this with a semicolon. This is not like JavaScript where you can be lazy about your semicolons. If you don't put them in, specifically in MySQL, there may be other engines that don't care, but in MySQL, if you don't put in your semicolons, it will complain at you. Let's run this query and see what comes back. Oh, we failed. Test bands doesn't exist. Okay, this is something that I forgot and no one could have been expected to know. We need to also switch into the context of the database. The schema SQL and the query SQL fields are sort of run in apart from one another. They don't really share the context, so we have to switch the context again. Once we do this, we should be good. All right, there we go. And now the downfall to doing this is that we're always going to get this query one, there are no results to be displayed. We're always going to get that, but we have to have it here or else we're not pulling from the right database. We're not, SQL doesn't know what database to look at. So we just ignore this. This is the result of our actual query that's here on line 3. We've got the name column, and we've got all the names that those inserts from the data.sql file that we just pasted into schema. Those are all the bands that those inserted. There's one more piece to this, and it's right here. Change the name of the column the data returns to band name. Let's do that really quick. It's pretty easy. We're still selecting name, but we don't want it to be name in the end. We want it to be something else. For that, we use the keyword as. And now after that, we can put in what we want it to appear as. We could just type a capital N. I'm pretty sure this will work. Let's see. Yeah, that works, but that's not exactly what we want. We want it to say band name. That does not work. And the reason this doesn't work is because SQL ascribes meaning to spaces. If you don't want the meaning to have, if you don't want the space to have meaning, then it needs to be in basically a string inside SQL. So we can surround that with quotes. I think this will work. Yeah, there we go. And you can see now the column name is band name. Michael asked if this code gets pasted right under the other code, talking about, I assume, the data.sql inserts. And yes, those do get pasted right under the other code. In fact, they will not work if you try to put them above, because the tables have to be created before you can insert the data into them. And they would not work if you tried to replace the creates for that same reason, because the tables need to be created and then you can insert the data into them. And Cassie asked what you click to run it. Yes, it is run at the top. You're correct on that. You can also, I think you can also, let me test this. On my Mac, I believe it is Command Return will also run the query. Yes. And on Windows, it should be Control Enter to run the query. But yeah, the run button works just fine. All right. We got 2 exercises down. Let's keep going. See what else we can, see what other damage we can do here. Now we want to select the oldest album. Make sure to only return one result from this query, and that you are not returning any albums that do not have a release year. Okay. This is a select query, but with a couple of interesting wrinkles. 1, we need the oldest. 2, we need only the oldest. And 3, we don't want to return anything that doesn't have a year. So those are going to make some changes to the way we do our query here. I don't need this query anymore, so we're just going to sort of do away with it. Okay. And now we're no longer selecting from bands. This is where I'm going to start, just because this is where how my brain works. We're selecting from albums. What were the columns we wanted? Looks like everything. Is that everything? Are there more than 4 columns in album? 1, 2, 3, 4. No. Okay. If you want to if you want to select all the columns, you can use the asterisk, and that'll just give you everything. You don't have to name each one. But let's just run this query and see what this does. Okay. It at least has the columns we want, so that's good. We do have some null release years, so we don't want that. Actually, let's fix that problem first. We don't want the release year to be null. If you want to filter the results of your query, you can use the keyword where. And then you just put a condition to the right of where. The column that we want to care about here in this condition is release year. And we want to make sure that's not null. The way you do that is really easy. You just say is not null. Let's run this query. This should be the same. It looks like that's the only null. So this should be the same result except without master puppets. And it looks like we're good. You notice these are sorted by ID by default, and we skip over 4. That was the position of master puppets. We're just sort of whittling away at this query, getting it down to where we want it to be. The next thing we want to do is we could approach this one of two ways. We could say we only want to return 1, or we could say we care about the age. I'm going to start with we care about the age. And I'm going to say let's make it so that we can see the oldest one first, and then we see them by release date from the first one. To do that, we can go to our query, and we can add a couple of keywords, order by. And now we just define the column we want to determine the order. In this case, that's going to be release year. And then you can also add the direction. There's ascending and descending. Ascending meaning going up, descending going down. In this case, if we want the oldest one to be first, then we want to ascend as we go down the table. And that is ASC. Descending would be DESC. Let's see what this does. Okay. Now, if you look here at the IDs, they are no longer ordered by ID, and they are ordered by release year. All right, we just have one thing left to satisfy, and that is that we're returning more than 1. This one's super easy. The keyword is just limit, and then you put the number. So in this case, 1. Limit 1. We could limit it to whatever number of responses or number of results we wanted back. Let's do 5 just to see what that looks like. There are the 5 oldest albums in the albums table. And now let's go for just 1. And that gives us the table we were looking for. And justice for all. Let's make sure that matches. Yep, that looks good. We are ready to move on to the 4th one. Looks like we've got some discussion here. Command return. Is command return to run the query common across SQL tools? What I can say is that a lot of SQL tools I have used use command return or control enter to submit a query. I don't want to say it's 100% common, but it is fairly common, so yes. And Guy says, can you hold on your songs table schema? Oh, okay. And Cassie, looks like Cassie chimed in with that there, so thank you for sharing that. Did that help you, Guy? I will start reading the next one, and I'll jump back and see if you got through that. Okay, for number 4, we're going to get all bands that have albums. There are multiple ways to solve this problem, but they will all involve a join. Return the band name as band name. Okay. I'm not seeing anything from Guy yet. I'm going to go ahead and get started on this one. I will check back in with you though. And if you're still stuck, we'll do whatever we can to get you caught up. Okay. We need another query. We're going to query bands this time, but we also need to know if they have albums. That's a little bit different from anything we've done before. We're going to select from bands. Oh, while we're here, the easy part, we're getting the band name and returning it as band name. We did that once already. Name as band name. Let's just run this and make sure it does what we think it should do. That looks right. Okay. The next step, now we need just the bands that have albums, and this will involve a join. What we're going to do here is we need to join. That means we need to put two tables together based on where the records are related. The way we do that is we go out here after our table name that we're querying, and we join another table. The other data we care about here is albums. So that's what we're joining. We're joining albums. Now, when you join, you need an on keyword, and this defines the relationship. What we're going to say here is we're going to offer a condition that SQL can use to compare records in the bands table to records in the albums table that will allow it to decide whether those are related or not. Looks like Guy's up and running with the songs table. Thank you, Cassie, for the help. Okay, we're going to join albums on. And now what's the relationship here? The relationship is the band ID. Oh, actually, we're going to have to do a couple things here. Now that we're involving two tables, we can't just take these column names for granted, because guess what? Both bands and albums have name columns. So once we start mixing these tables together, how will SQL know which name we care about here, which name we're actually selecting? And the answer is that it won't unless we tell it. So what we can do is we can say bands.name, and that will sort of scope name to the bands table. And that's going to be helpful here too. We're going to compare albums, if I can type it, dot band ID equals bands.id. So this means if the album's band ID matches the band's ID, those two are related. They're going to be joined. Now, what can we do with that, and why? Why did we do that? We did it because we want to see if bands have albums. Let's run this query and just see what it gives us. All right. So what we're seeing here is we're seeing for each album in the albums table, we're seeing the band name. The good news is that means we're only seeing bands that also have an album. And that was what we wanted. We only want to see bands that have an album. Now, how can we make sure that we're only getting one instance of each of these band names? Because that's really all we want to see. We can do that with another keyword called distinct. Distinct meaning just different from all the rest. So now we're selecting the distinct band names, and we're joining with albums. So that's giving us only the bands that have albums. And that is the result we want. Let's compare it to the other one, just to be sure. Seventh Wonder, Metallica, The Ocean, Within Temptation, Death, and Van Canto. That looks right. That one's a little tricky, a little bit tricky. All right. Fifth exercise is sort of the inverse of that one. We need to get all bands that have no albums. This is very similar to number 4, but will require more than just a join. Still returning the band name as band name. Okay. Here's what we're going to do this time. We're going to change this from a join to a left join. And, you know, this is a good chance to sort of show you how you would use the reference if you were not sure about something. And actually, you might not know that you needed a left join. Here's the documentation for the join clause. The first thing this documentation is going to give you on any command or clause or whatever is just this massive dump of every possible variable that you can have here. But then if you scroll down past that, you're going to start to get some good information. And I have a short attention span, so I just kind of scroll until I find what I'm looking for. Join, cross join, inner join, are syntactic equivalents. Let's see what else we've got. An inner join. There are different types of joins. Yeah, this is kind of where we need to be. If there's no matching row for the right table in the on or using part of a left join, a row with all columns set to null is used for the right table. Okay. The natural left join. Right join is analogous to the left join. Most, or rather, a lot of relational databases do not implement a right join. So they're suggesting you just flip it around and use the left join. But they haven't really, or maybe I just haven't read deeply enough. Yeah, here we go. On left table ID equals right table ID. Yeah. So what this means, a left join cares about whatever's on the left side of your equals sign. So that table, every row from that table is going to appear. On the inner join, which I believe is the same, I think they said that's the same as just the join. Yeah, the join, cross join, and inner join are the same. On the join, which is what we did before to find the bands with albums, you're only going to get results that have relationships between the two tables where each row or each table is contributing to that relationship. That means even though we're selecting from bands, we don't get anything on a standard join when there's no album, because both tables have to have data in order for the record to show in this in the inner join. Now, if we go to the left join, that means we're going to get every band, whether it has any albums or not. Let's test that. I don't know which one was missing, but I can say this definitely looks like all of them. Actually, I guess we could look. Dream Theater. Is Dream Theater there? They are. So now we need to figure out how to make it so that they are the only ones there. We know that means we want to filter, so we're doing where. And what do we want to filter on? We want to filter on the albums. To do this, we can use what's called an aggregate function. It is a function that lets you take a relationship where there are many related items. Like, you're only going to have one instance of a band, but a band will have multiple albums that are related back to that band. An aggregate function lets you take all those related records and sort of combine them into one thing in some way. And we're going to use sort of the simplest one. It's just count. And the count function has to be called on a column. We don't really care what gets counted on the album. I'm going to just count the ID. That's just going to give us a count of the number of matching of related album records for any one band. And I want to make sure that count is 0. Oh, invalid group function use. Okay, this is not correct. And the reason is because when you use an aggregate function, you have to group your results. So we have to say, we have a record that is related to multiple things. What is the important thing that we want to look at? And in this case, that is the band ID. So we're going to define that using a group by keyword. Group, sorry, band.name. Let's try that query. You have an error in your syntax where count ID equals 1. Let's see if we can figure out what this is. I'm actually gonna go outside of the official documentation here because I think it'll be more useful. Let's just sort of search this. I know this is kind of specific to our situation, but I'm going to go out on a limb here and guess that other people have tried this. And it looks like I might be wrong. Let's see. What was our error? No, it's just a generic parse error. This is probably not going to give us anything. Let's look at the documentation for our select statement. One thing I notice in the syntax here is there are two different ways to specify a where condition. There's where, which we've already used, and then there's having. So maybe we have chosen the wrong one. I'm going to do a find on this page and try to get an explanation of what the difference is. I'm just going to Command F, Control F would be your key on Windows. We're going to look for having. Of course, it's there. And here we go. Okay, this is not anything specific about the having clause. That doesn't really tell us anything useful. This tells us that the having clause is applied nearly last. Okay. The SQL standard requires that having must reference only columns in the group by clause or columns used in aggregate functions. Okay. Preferences giving. If a having column is used in both group by and as an alias column, do not use having for items that should be in a where clause. For example, do not write the following. The having clause can refer to aggregate functions, which the where clause cannot. That is the key there. So let's head back over here and let's try just swapping this out. Not quite. Unknown column, band.name, in group statement. I left an S off. Okay, column ID. Oh, gotcha. This is a very helpful message. I like it when messages are very explicit. Column ID in having clause is ambiguous. We don't know what that means. This should actually be albums.id. And now that is what we are looking for. This is a query that produces just the bands that have no albums. All right, looks like we've got some discussion. Left, inner, right. Moses, I think, is providing a sort of visualization there and how the different joins work. I took you on a little bit of a journey with that one. I hope it was more helpful than confusing. I like to leave some of those rough edges on so that you can see how you would solve them if you got to them without me, rather than just kind of spoon feeding everything to you. Let's get on to this next one. This is get the longest album. Sounds a lot like number 3, but the solution is quite a bit different. I would recommend looking up the sum aggregate function. Let's go ahead and do that now, just so we are prepared. All right, first result here, when we type sum into the MySQL documentation search, is aggregate function descriptions. Here we have sum, return the sum. Seems pretty straightforward. Returns the sum of expression. All right. And we are getting the longest album. That is significant because if we look at the albums table here, it doesn't have a length. Only the songs have a length, which means this is going to require us to join again. We're going to have to use two different tables. And the tables we're going to need are album and song. What do we ultimately want to show? The name, the release year, and the duration. Okay, let's just start. Let's start from select. We know it's a select. We're going to select name. Oh, and we know this is a join. So we'll go ahead and specify the table. Select albums.name, albums.release year. What did they call the other one? Duration. There's not a duration though, so we can't select that column. We do know that sum gives us a sum of a bunch of values. So what we're going to do is we're going to use that function. And what are the values we need? We need the length of the songs. So let's try summing that. And we're going to call that something else. We're going to call it duration. I think we want to call these other things too. We just at least want to capitalize name, and then we can format this nicely as release year. And this is getting hard to read, so I'm going to do a little extra formatting here. SQL doesn't care about how much spacing you have, so you can kind of format things however you like to make them look nice, make them easy to read, and it will still just work. Okay. Now we're selecting this from the albums table, but we're also joining the songs table. What is our relationship there? It is songs.album ID. That's the foreign key, and it references the album's ID field. So that's going to be equal to albums.id. All right. And, let's run this and see what it does. Nothing. An aggregated query without group by, expression number 1 of select list contains non-aggregated column, recordcompany.albums.name. Okay. Albums.name has not been, it's not aggregated and it's not grouped by anything, or it's not in a group by, rather. Let's group this by albums.name and also by albums.release year. Let's try that. Join songs on songs.albumid equals albums.id. Did I? Oh, this. Some statements have to be in a specific order, so you want your joins after your from, and then group by, I believe, is always last. Actually, I think I read that in the query documentation, in the select documentation. That was a simple enough fix, and it looks like we've got what we want here. Let's just look at a couple of these values and compare them. And justice for all is 65.55, and then a bunch more stuff. Oh, actually, no, I'm sorry, we're not done yet. We're getting the longest album. For this, we can do kind of what we did before. What was that we had to do? We had to, oh yeah, we got the oldest album, so now we're going for the longest album. And we're most of the way there. Now we've just got to do stuff we've done already. Okay. Now we want to order by, we only want the longest album and we only want it. So we need to order in the descending direction, and we're ordering by, I think you can do this. Actually, I'm not sure that you can. I think you have to use the aggregate function there. Order by the sum of the length. And now we need to limit it to 1. Oh, also we're ordering descending. So that way the longest one will be at top, then we'll limit it to 1, so we'll only see the longest one. Let's see if that works. Death magnetic, I think that was it, 74.76666. Yeah, that looks right. All right. These are getting tougher as they go. How's everybody right now? Anyone having problems? I'm checking back occasionally, even as we're doing these. So I am trying to stay on top of any questions in the chat. Although it is much more challenging now that I've had to leave the room that has my nice additional monitors that I can just keep the chat on. But my computer does run a lot better. Okay, I'm going to keep going. I will continue to check back, so please let me know if you are having problems. Update the release year of the album with no release year. Okay. Set the release year to 1986. You may run into an error if you try to update the release year by using release year is null in the where statement of your update. This is because MySQL Workbench by default will not let you update a table that has a primary key without using the primary key in the update statement. That's sort of a safety feature to make sure that you don't change records that you don't actually want to change. If you said update update all records where release year is null because you knew the one you wanted to update had the release year null, you could potentially change some other records as a side effect of that. Okay, let's head over and try to do this. First, we don't really know anything about the update. Here's the update statement. I like to see an example. Here we go. Update T1, that's, I assume, the table name, set, and then we've got a column name, equals, and then some value. In this case, they're just adding 1 to the value that's already there. And here is what they're going to do to set the value in multiple columns. I think that is straightforward enough that we can probably just do it. And this, since this is intended to be a persistent change, in other words, this change is supposed to stay like that, I think I want to do it in the schema column, because that way it will just always be there. It will be changed to that every time. Now, what we need is we need the, here it is. This is the one. We need the ID of this album. And I know that the ID column is in the first position. So the value that's put into that is also going to be in the first position. The ID is 4. I'm going to give myself a couple lines here. Update. And I've already forgotten what the syntax is. The table first. Update albums. Set. And I'm setting release year as the column I care about. I'm setting it equal to 1988. And now I'm going to need a condition. And here's an example of how that works. Update items month. Set items month. This one's a little more complicated than we need. Yeah, actually all of these are a little more complicated than we need. But the where statement, or the where clause, works just like it does in a select. So we're going to say where, and then we're going to set out a condition, and that condition is ID equals 4. Now that's great, but if we run that, it won't really verify. We won't have a great way to verify that it did what we wanted it to do. Sure, we'll see an error if there's a problem, but we won't see anything else. So let's come up with a select query that would prove to us that that did work. I see that Cassie is having a problem. Can you tell me what is happening, what's not working for you, and I'll try to help you work through it, Cassie. All right. While she's doing that, I'm going to try to write this select. Okay, this could be really simple. I can just select everything from albums, and then we can just look for that one and make sure it got changed. That was Master of Puppets, right? There we go. Looks like we got the new release here, so I think we are good there. Let's move on to the 8th exercise. Insert a record for your favorite band and one of their albums. All right. Oh, sorry, I was in the middle of that. This one is also going to go in schema because this one is sort of a persistent change. We're inserting a new record, and I don't really need to see the output from that. So we'll just do it here in the schema. Insert bands. And actually, we don't know how to do an insert statement either. Let's look that up. Just reference that here in the documentation. Insert into table name, and then you have a set of parentheses, which are set aside for your column names. Then you have values, and you have your values that you're storing for that record. We have seen these before. Actually, we pasted a bunch of them in here and kind of took a look at them. So now we're doing our own. Oh, it's insert into, then our table. And now we need to define the columns we're going to use. I need to go back up in the schema to refresh myself on which columns we have for bands. We just have an ID and a name. And really, I don't care what the ID is. It's already set up to auto increment. So I can just leave that up to the database. I do want to specify the name though. We have values. And the value, I'm not going to commit to this being my favorite band, but I did like this band a lot as a teenager. So we're just going to go with it. We're going to do the Offspring. Let's run this and make sure that works. And the way I'm going to verify it is going to be similar to what I did for that release year update. I'm going to select everything from bands. Just see if that record goes in. There they are, right at the bottom. Okay. And we also want to insert one of their albums. Insert into albums. Okay, let's go back up to our schema and see what columns albums has. It has an ID, it has a name, a release year, and a band ID. I don't care about the ID again. I'm fine with MySQL assigning that ID. I do want to put in the name and the release year, and I will need to specify the band ID. MySQL, unfortunately, has no way of knowing that whatever album I'm about to put in is by The Offspring. Oh, got it working. Great, Cassie. Thanks for the update. Okay, back to our insert here. The album I'm going to put in is Smash. An old classic from 1994, I believe. Now we're in a difficult spot because we're letting the database assign an auto-incremented ID. There are a couple of ways we could approach this. We could just go back up to our other artist inserts and say, okay, well, we know this artist is going to be inserted after the other ones, so what would their ID be? And their ID would be 8. And if we look here, we can tell that that did play out. The thing is, usually when you're doing stuff like this, you may not have that knowledge ahead of time because, especially if you're adding data to an app that's used by lots of different people, you don't know how many inserts have happened and what those have been. So you can't really predict it like we can here, where we just have this really controlled environment. So what I'm thinking is I want to do this in such a way that it doesn't matter what happens between those initial band inserts and my band insert. I can always know what the um, ID is. And what I would do is I would go and search for last inserted record ID MySQL. Ah, this looks promising. Last insert ID. I trust Stack Overflow in general as a source, so let me look at that answer and see if this helps. Okay, so apparently there is a function in MySQL that will just give you the last ID that got inserted. Let's see if we can find documentation for that. Not that I don't believe it exists, but it would just be nice to read what it's all about. Oh, did I spell that right? No, last insert ID. Okay, here we go. Within the body of a stored routine or trigger, the value of last insert ID changes the same way as for statements executed outside the body. Okay, let me just click through on this because I think that documentation is actually about last insert ID inside the context of a stored procedure and function, which is something we're not even going to get into, and you can really go a long way without having to go into that, in my opinion. But anyway, with no argument, last insert ID returns a big int unsigned value representing the first automatically generated value successfully inserted for an auto increment column as the result of the most recently executed insert statement. Okay. That's a very long-winded way of telling us that this just gives us the last inserted ID. So let's just use that. Last inserted. Nope. Try to do it again. Last insert ID. Now, that insert statement should be durable no matter what ID the offspring ends up getting. Okay, well, it worked, but we didn't create any select that would verify it for us. So let's just write another one, and we'll select everything from albums. Okay, we've got all the bands here. There is the offspring at ID 8. Let's see if we can find our album. There's Smash, and the band ID for Smash is 8. Let's do a thing here, just to show you why we went to all that trouble instead of just dropping an 8 into that column. I'm going to go back and add another band, and I'm also not going to specify that ID here because I really don't care what the ID is. And what's another band? Let's say Green Day. I guess you can tell where my head is right now. Okay, let's try that. Okay, let's see what we have now. Now we have Green Day with band ID 8, and the offspring have 9. If we had hard-coded that 8, this database would think that Smash was an album released in 1994 by Green Day, and that would not be accurate. I'm going to take this out now. That was just a quick demo, but you can see why that is valuable, I hope. Let's see what we've got next. Oh, delete the band and album you added in number 8. All right. So I guess this insert wasn't as long lasting as I had hoped. Now we need to figure out how to delete stuff. Delete statement. That's probably what we need. The delete statement deletes rows from table name and returns the number of deleted rows. Let's see if we can just see a simple example. Delete from where, okay. So it's kind of got the sort of familiar structure of a lot of these commands that we've already seen. Let's flip back over and see if we can delete those two. First, we want to, oh, interesting point here. The order of how you delete the records is important since the album has a foreign key to band. That means if we tried to delete these in the same order we added them, if we tried by deleting the offspring first, MySQL would complain because there is an album that is related to that band. That means we will need to delete the album first. Delete from albums, where, and I'm just going to do this by name. I think that's as good as anything. Ooh. Name equals smash. Okay, let's try this first. All right, just checking in on the chat here. Moses, I appreciate the pun. I'm a pun. I think of myself as a pun aficionado, so thank you for bringing that levity to the chat. And Michael, thank you for stopping by. Hope you got something out of it. Let's get back in here. Oh yeah, so what did we do? We deleted something. We deleted our album. Let's go make sure that's gone. Yep, looks like the album is gone. Now we can delete. Oh wow, we got some weird funky spacing here. This is something I noticed earlier. I think this is just a quirk of this DB fiddle. So normally when you press return, you shouldn't get that sort of spacing, but I think when you get down to a certain line number, it does it here for some reason. Let's delete from bands where name equals the offspring. And we'll see if that works. The query succeeded, and we no longer have the offspring in our bands table. Looks like we're good there. What is up next? Oh, also, since we just wrote two statements and then canceled those two statements out, I'm just going to go ahead and delete all of that. No sense in keeping it in there. Get the average length of all songs. Return the average length as average song duration. We don't know how to do this, but we do know that there are aggregate functions, and one of those is sum. My thinking is that something like an average might also be one of those. Let's check in the documentation and see if that plays out. Return the average value of the argument. Returns the average value of expression. Okay, that sounds like what we're looking for. This is going to be a select statement, so let's go back to our query SQL editor. We want the average length of all songs. Okay, select. So what do we want to actually see? We want to see the average of length. from the songs table. And I think that's it. Let's try it. 5.352. Looks like that's right. They do want it to return as average song duration, and that is going to be a pretty easy change to make. Average song, nope, duration. There we go. Okay. Now we want the longest song off each album. And we need this to bring back the album, the release year, and the longest song length as duration. Let's flip back over to our aggregate functions. Maybe one of those will help here. We've got max that returns the maximum value. Here's how that's used. Select student name, minimum test score, maximum test score from student, group by student name. Okay. I think we could pretty easily map that on to what we're doing here. Album, release year, and longest song. Oh, actually, this is a little bit more complicated because we've also got a join here. The songs and the albums are not in the same table, so we need to join the albums table with the songs table in order to get all the data we need to produce this output. Let's start from this select. We're going to select albums.name as name release year, albums.release year as release year, and maximum of songs.length as duration, I believe it was. Yes. Okay. Again, I'm going to format this a little bit just to make it easier to read. Okay, and all that is coming from albums. But we need to join. And what do we need to join? We need to join songs on songs.album_id equals albums.id. Okay, and then we're going to group by the albums.name and the albums.release year. Is that everything? I think so. Let's see if this works. I probably missed something. Oh, maybe not. This looks reasonable. Let's compare it to some of their values. And Justice for All is 9.8, A Storm to Come 5.2. I don't think theirs are ordered the same way. And Justice for All 9.8, A Storm to Come 5.2. So that looks like what we want, I think. All the columns named correctly? I think so. Okay, cool. That was actually a little more straightforward than I thought. Oh, we're at the last exercise. Unbelievable. I cannot believe we made it this far. Let's check the chat. Looks like nobody has any questions or anything right now. Um, be sure to jump in with those if you come up with anything. Now we need the number of songs for each band. This is one of the toughest questions on the list. It will require you to chain together 2 joins instead of just 1. Oh boy. First time doing 2 joins. Okay. Return the band name as band, the number of songs as number of songs. Okay. I think we're ready. I think we're ready to tackle this. I'm not ready. What do I need? The number of songs for each band, right? The band and then the number of songs. Select bands.name as name. And now we don't really need, oh, I got 2 S's in bands. And we need the number of songs. I know before we used count for that, and we can just count whatever. We'll count songs.id. And what are we calling it? We're calling it number of songs. Count songs ID as number of songs. We're not going to select that from albums. We're going to select it from bands. Okay, and we need 2 joins. Why do we need 2 joins? Because the songs don't relate directly to bands. The songs are related to albums, and the albums are related to bands. So the first thing we need to do is we need to sort of glue bands and songs together by joining albums. And we're going to join it on albums.band ID equals bands.id. We're going to follow that up directly with another join. This is going to be join songs, not that. Okay, songs on songs.album ID equals albums.id. That should give us access to all the data we need to produce these results. Let's look again. Band and the number of songs. I'm going to change this. That's supposed to be band. Okay. What are we grouping by here? We're grouping by bands.name. You know, I think that's it. Let's run this and see what happens. That looks reasonable. Seventh Wonder, 35 songs. Metallica, 27 songs. Death, 27 songs. The Ocean, 31. Yep, that looks like it. All right, the final exercise. We tackled all 12. We did it together. I hope you learned something about MySQL. This is an incredibly valuable skill to have, especially if you're doing web development. Just about every project I've worked on has touched SQL in some way. So I think this will make you a much more marketable web developer. I want to thank everybody for joining me, for hanging out for a couple of hours. It's been a pleasure teaching you SQL. If you want more stuff like this and also stuff about your career and other topics related to transitioning into careers in web development, then subscribe to my channel. You can also check out my website. I've got a bunch of stuff there at raddevon.com. and I wish you all the best. Thanks for watching.